a semicircle is 90 degrees. What does that even mean? So today we're going to be talking about circle theorems. There are about 8 that we need to talk about, but I'm going to have to do them one after the other in different videos at different times. As you can clearly see, I don't have the projector with me right now, so I had to write on a piece of paper or in a notebook. So the angle in a semicircle is 90 degrees is the first of the circle theorems because it's quite easy to understand. I'll explain it. Now, when you have a diameter which cuts across the middle of your circle then becomes a semicircle on one part and the other part is also a semicircle. So this is a semicircle, that's a semicircle, which means half of the circle. So my diagram might not be accurately drawn, but please understand that it's a freehand drawing. Now, once you have drawn your diameter to cut across your circle, your diameter automatically becomes the hypotenuse of a triangle you draw inside the circle. So this will be your hypotenuse, which is of the hypotenuse of any triangle you draw there. Then the opposite side to your hypotenuse will always be 90 degrees. So this bit here is 90 degrees. The whole of this bit here is 90 degrees. However, you should understand that if I was to split this diameter into two, I would have one radius here, another radius here. 2 becomes radii. Now 2 radii gives 1 diameter. So if I cut it across, this is another radius, isn't it? So that's 1 radius there. Now it's coming from the center point. It means this bit and this bit are equal. So you now have a new triangle here from the old one that we had before. So this was our diameter. This was our 90 degrees because it's opposite the diameter. So we know that's 90 degrees. However, we have now cut across from the middle point down to that bit there, like that. So what then happens? It becomes an isosceles triangle where the base angles become the same thing. Same on the other side. This bit and this bit will have this bit and this bit to be equal because that's one isosceles triangle, and the other one is also an isosceles triangle on that side. Isosceles triangle on the other side as well. So if I have something like this, where this bit here is 55 degrees, and you're asked to find x. Remember, this is your hypotenuse. The opposite side is what? 90 degrees, remember? So if the opposite side, that's the pen. If the opposite side is 90 degrees, what could this be? Now, angles in a triangle add up to 180 degrees. So 90 add 55 is 145. And of course, this bit, if you take 145 away from 180, you would have 35 degrees remaining. So your x here will be 35 degrees. So 55, you know that is 90. Why? Because the opposite of the diameter or the opposite of your hypotenuse is 90, because angle in a semicircle is 90 degrees. Now, if you come here, you have 2x and x, and you're asked to find x degrees. The same thing like the first one we've done. Yeah, we know the whole angle there should add up to 180 degrees. So if I have 2x degrees plus 1x degrees, I don't need to write the 1, plus 90, because I know this will be 90. So plus 90 degrees equals, angles in a triangle add up to 180 degrees. So you have 3x degrees plus 90 degrees equals 180 degrees. Now 3x degrees equals 180, take away 90, because you have to eliminate this 90 from this side. You have 90 degrees. So now to get x, I divide both sides by 3, and my x degrees will be 30 degrees, or my x will be 30 degrees. So x here is 30 degrees. We're using these examples to be able to understand what the angle in a semicircle gives. Now, if you look at this one here, this is a radius here. So you can clearly see once it's gone from here to here, that's a radius, that's another radius. It changes this into an isosceles triangle, like I said before. Now, the base angles of an isosceles triangle are equal. So if this is 66, then this D automatically is 66 degrees. All right? Now, you know that the whole triangle here, this bit, yeah, and this bit should add up to 180 degrees without this radius that has cut across it. Yeah, so what you can do is, this is your diameter, guys. Don't forget, remember this whole bit here is 90 when it's opposite the diameter. Yeah, so your 90 plus your 66 would give you 156 degrees. Now, if you take 156 degrees from 180, you would have 24 degrees left. So it automatically means this C is 24, because that's 66, that's 90, that will be 24 degrees. All right, so we now know this is 24. We know this is 66. We now need to look for E, F, and G. All right, now you know that these two here would add up to 90 degrees because it's opposite the diameter. So if I know D is 66, my E will be 90, take away 66 degrees. And so that's 4 there. 8 take away 6 will be 24. Am I right there? Yeah, 24. So your E here is 24 degrees. So I'm going to write 24 degrees for my E there. All right. Now, if I know this is 24, and I know this is 24 because we already worked it out, yeah? 24, 24. Can you rightly see that we have one isosceles triangle there? You can clearly see that isosceles triangle. This is a radius, this is another radius. So can you see it does make sense? The base angles of this side should be equal. So my E and C should be 24, and that's exactly what we got. So that's really good. Okay, so if E and C is 24, that makes 48. To get this G, I have to do 180 take away 48, and I'll get 132 degrees for G. So my G is 132 degrees. All right, so now if my G is 132 degrees, remember this is 66 here. D here was 66 as well, which is 132. To get my F, I'm going to do 180 take away 132 degrees. So that's 8 there, 7, that's 48 degrees there. So my F there is 48 degrees. So we're going to go back here. It's very important that you know that once your diameter has cut across the middle of your circle, it's changed the top and bottom into semicircles. Now, when you draw the triangle, whatever side is facing is opposite the diameter is your 90 degrees. Now, if you are to cut a radius from the middle to the circumference, then it automatically changes each of the triangle into isosceles triangles. And the base angles of isosceles triangles are equal. So please remember the way we've done this bit here. The next one we're going to talk about will be another theorem entirely, which we will do probably when I get the right equipment to draw my circles and all that. Because schools are locked now, we are not really having the tools to use. But do bear with us for today. See you soon.